Hello, my name is Professor Dinglebrackydoo, and today I'm going to explain to you the hydrogen isotopes of deuterium and tritium. Let's take a walk to my lab. As I said, deuterium and tritium are hydrogen isotopes. Now, today I'm going to explain to you exactly what their properties are. I'm going to explain their atomic mass, electron structure, and so on. First, we're going to look at deuterium. But first I'm going to explain to you exactly what an isotope is and what they look like. Let's look. This is an example of an isotope. Look on the right and you'll see deuterium. Look on the left and you'll see hydrogen. The deuterium is heavier and larger than the hydrogen because it has more neutrons than normal. An isotope has more neutrons than its element counterpart. This makes all isotopes larger and usually more unstable. I hope you know now what an isotope is. This is a normal hydrogen atom. Notice how it only has one proton and one electron, but no neutrons. This is deuterium. Notice it's almost like a normal hydrogen atom, except for the fact that it has one extra neutron. This extra neutron makes it one atomic mass unit heavier than a regular hydrogen atom. This is tritium. It is the second hydrogen isotope. Notice again that it has one more neutron than deuterium. I hope you now understand what we'll be looking at when we discover exactly what deuterium and tritium are. Now that you understand the isotope, we will now look into deuterium.
Hey there, I'm Deuterium, and I'm going to tell you a little bit about myself. My atomic number is 1I, because I'm the first hydrogen isotope. My atomic symbol is 2H, or D. My atomic mass is 2.01. My mass number is 2. And I have one electron. That was predicted in 1926 by Walter Russell using his spiral periodic table. I was discovered in 1931 by Harold Urey before the neutron was even discovered. He won the Nobel Prize because of me. And now here's some things I'm used in.
I'm in a substance called heavy water. It's just like normal water, except for instead of hydrogen, there's deuterium. From heavy water comes a heavy water reactor. I'm not sure how it works, but I do know that it makes stuff that go boom. I am also in the ocean. In fact, there's one of me for every 6,500 hydrogen atoms. I am found a lot in Jupiter and brown dwarf stars, but I am not found in the sun. Lastly, I am a key element in nuclear fusion, but we'll talk about that later.
And that was deuterium. Now, we're going to look at the other hydrogen isotope of tritium. Now, tritium's a bit on the unstable side, and a little radioactive too, so you better look out for him. Hey, I'm tritium. I'm going to tell you a little about myself. Well, my atomic number is 1II, because I'm the third isotope of hydrogen. My atomic symbol is 3H, or T for tritium. My atomic mass is 3.01, kinda like my cousin deuterium. My mass number is 3, because I have 2 neutrons and 1 proton. I only have 1 electron, just like everybody else in the hydrogen family. I don't know what's up with us. Because I'm radioactive, I have a half-life. That's how long I stay radioactive. My half-life is about 12 years. I'm not too dangerous, so I'm not gonna hurt you unless you start drinking me instead of water. Here's a little bit about my creators. I was predicted to exist in the late 1920s, again by Walter Russell and his spiral periodic table. Boy, he discovered everything, didn't he? I was made in 1934 by a man named Ernest Rutherford and 2 other guys whose names I can't pronounce. Well, That's it. Now here's a little bit about what I'm used in.
Because I'm radioactive and naturally luminescent, I'm used in a lot of things that glow, such as glow sticks, the emergency backup power for exit signs, I help you see your watch face when it's dark, and I'm even used in gun sights to help you see when you're shooting at night. Oh, and I'm also used in fusion and nuclear bombs and power and all that sort of stuff. But I'll go over that in a little while. Oh, and because it came up so much in our research, we've decided to include an example of Walter Russell's spiral periodic table. If you look closely, you can see at the top off of hydrogen, deuterium, and tritium.
And that was tritium. Well, I hoped you liked our presentation today on deuterium and tritium, the isotopes of hydrogen. I hope you'll research them because they're very interesting. Now, before we go, I want to show you something that we've been saving till the very end. Fusion. Specifically, nuclear fusion. That's when a deuterium atom meets a tritium atom. They come at each other and fusion happens. That's a nuclear bomb. Let's take a look outside. Fusion! Now I'm a neutron and he's helium. Oh.